Hey guys, what's up? My name is Meredith and I am part of the Bridge Year team. And I'm so excited that you're joining me today. And the whole purpose of Bridge Year is to create things like career kits for you and other students so you're able to try out and explore all different careers and figure out what might be a good fit for you. So let's go ahead and jump in. With me today, I have the medical lab technician career. And maybe that's a term you've heard of before, maybe it's not. And who these people are, they are the people working behind the scenes in the healthcare industry to analyze and test different bodily fluids and tissues of patients so they can run tests, analyze the tissues, and report those findings to doctors so they can properly treat and diagnose their patients. Common bodily fluids tend to be blood and urine, which, icky, sounds kind of gross, but they're so important because you can learn a lot about someone's body just from a tiny sample of either of those. So, what is our task for today? I need you to imagine that I am actually your lab manager. You are a new medical lab technician in St. Sophia Grace Hospital. I need you to figure out for a patient who needs an upcoming blood transfusion if there'll be a match with a donor blood sample we have in the lab. So in order to do this, you're going to have to be able to figure out their blood type, this patient's blood type, and do something that I'll teach you later is known as a cross match to figure out if they'll be compatible with this donor blood. So, as true with most medical lab technicians' work, you're going to have to rely on some biology and chemistry, but don't worry, I'll be with you every single step. So go ahead and pull things out of your box, and I will explain what all you need and why it is important to get us set up and ready to go. So I already pulled a few things out from the supply bag. There should be 4 pipettes, which are here, and that'll allow us to mix the serums that we use for testing with the patient's blood, as well as the donors, some writing instruments. These are black stirring rods to actually mix our liquids together in solutions. This right here is our donor's red cell. This is our donor's red blood cells right here. As you saw, I was putting on gloves while I was talking about those items from the supply bag, and we want to make sure we're following proper health codes and procedures, especially since we are working with blood. Yes, it's fake, but we want to make sure that we're going to mirror what's true in real life, okay? So now that I have my gloves on, I can actually open up this biohazard bag. Remember, we're dealing with bodily fluids, so we want to make sure that we have something to dispose of when we're done with our testing. So I have the patient's red blood cells right here. It's labeled, my patient's name is Glenn Holt. You will have a different patient name, but that's a-okay because it's the same exact process and procedures regardless of who the patient is. So as I said, here are the patient's red blood cells. There are 3 solutions that have this anti-labeling to them. You should have anti-A followed by anti-B and anti-D. I'll explain what those are in a little bit. And then lastly, you'll see that this is labeled as plasma. Plasma is a part of the blood that helps transport your red blood cells throughout your body. It's clear this is where antibodies live, which help with your immune system. Very, very important, but it does kind of have that yellow tinge to it. And then, as I mentioned earlier, here's our donor's red blood cells, and they are blood type A negative. In the manila folder, you should have 3 things. I'll put that in my box. The donor's identification card, giving us all the information about the sample. You need proper documentation to know what sample belongs to who when it's being donated. My testing panel we'll get to, and my patient's request form, which gives me all of his personal information, as well as why he's needing this transfusion. Apparently he has kidney disease, and that's why he needs this blood transfusion. And at the bottom is a space for us to use as documentation as we go through our testing, so we can record our findings, because not only is it about testing for being a medical lab technician, but also completing the proper documentation and paperwork. So there is a paper trail, so if there are any issues, you can always find the right tech and have something to refer back to if there's questions from the doctor later on. So these are all the supplies you should have out. The very first thing that we need to do is take these red blood cells and actually turn them into a solution. So when blood tends to be donated, it can be separated out into its different components. What we'll need to do to make this into a liquid that we can use for testing is we need to add hot water to those test tubes. And the reason why it needs to be hot is because our bodies are on average around 98 degrees Fahrenheit. So what we'll need to do as a next step is, if you have a mug, a cup, anything that can go into the microwave, I was able to find this clear bowl. But you want to get about half a cup of water that you'll put in the microwave for 30 seconds so it's nice and hot, because we want the solution to mirror what would be true of a patient's body. So I will be right back. I'm going to go put this water in the microwave. Go ahead and pause this video so you can do the same. Again, anything that can be microwavable safe. Half a cup of water, you really don't need much, and about 15 to 30 seconds just to make sure it's nice and hot, but be careful and don't hurt yourself. See you soon. I'm back with my hot water. If by chance you don't have a microwave, just try to get hot water out of your sink. Still put it in a bowl though, because, or a cup, whatever you have, we are only filling up to the
4 mm mark.
So we want to be super careful, and we'll use a fresh, clean pipette for each sample. So what I'm going to do is, I have my donor sample. I'm going to get that hot water and carefully look and observe to the, I gotta be super duper careful. A lot of the work as a medical lab technician is all about precision. I'll put the cap back on and then have gravity help me out and actually shake up that hot water with those red blood cells to make sure it gets fully incorporated. A tip that you want to know about is that at that very top of the, well, I guess it's the bottom of the test tube, it might clump up those red blood cells. So what I suggest you do is that you take that pipette and use it as you would a spoon and mix everything up, because you want to make sure that all of those red blood cells are being able to float around and fully incorporate so our tests are accurate. It is so vital that with all the testing that goes on with medical lab technicians is accurate, and it looks like we are good to go. So I'll just leave that pipette in there, and as you saw, I was doing some of that pumping motion, and that's just to check for clumps to make sure that there's not any problems or issues. And I repeat, I can put the cap off to the side, I repeat the whole process too for that donor red blood cells. I repeat the same process for our donor red blood cells, going to that
4 mm mark.
Making sure it's as accurate as possible. If you go a little bit over, it's a-okay. I feel like I get a little mini exercise in incorporating these two together as I shake up the test tube. In real life, medical lab technicians would have machines to do this for them and make the job a whole lot more easier. So again, same process of making sure that we stir, pump up, so there's absolutely no clumps. And once we have our patient's blood and the donor blood set, our very first task will be to blood type the patient's blood. We don't know at the moment if they're B positive, A negative, so that's going to be our very first task. And we can finally get into the testing portion of our task. So I set those red blood samples off to the side because our very first step is to copy down the patient information from their transfusion request form to the recipient information box on the testing panel, so we don't get confused on what patient we're working with, and that if we need to refer back to the information later, we are good to go. So my patient's name is Glenn Holt, so I'm writing down his name, his physician who's requesting that. We figure out if this blood is good to go for him for his blood transfusion, as well as his patient ID. So there's many layers to making sure samples and documentation does not get mixed up. Now, time to finally figure out the blood type of the patient. Test tube rack should have been set up with anti-A, B, and D in that order next to the patient red blood sample. We figure out a patient's blood type by mixing their red blood cells with serums. So on your test tube rack, I mentioned this earlier, it should go anti-A, anti-B, then anti-D. How do these two things work together to figure out blood typing? Well, on our red blood cells, there are markers on the outside known as antigens, and those antigens are used to figure out people's blood types and how we classify them. So that A positive, O negative comes from these antigens hanging out on the outside of our red blood cells. These three serums will tell us if antigens are present. So the anti-A serum will test for an A antigen. Anti-B will test for a B antigen, and the anti-D serum tests for the D antigen. How will we know if the antigen is there or not? Well, when I mix the red blood cells with the serum, if clumping occurs with the red blood cells, that's how we know the antigen is there. Now, how do we deduce blood type based on A, B, and D? Well, if you have, and there's clumping for the A antigen, which we'll see with the anti-A serum, then that means you have the A marker, or A blood. If you have the B antigen, which we'll know from clumping with this serum, you have type B blood. If you have both of these, you have type AB blood. If you have neither, and there's no clumping that occurs for these two, you have type O blood. Now last, you're probably thinking there's that positive negative part of our blood type. That comes from that D serum. So if our D serum clumps with the blood, that means it's there, so the blood is positive. If it's not, that means the blood type is negative. Okay? So let's go ahead and get into it. So, as I said, my samples are here. I have my testing panel. And the very first step is to take
4 drops of the blood
and put it in that anti-A testing well. Remember, we're looking for the presence of the A antigen on our red blood cells. If we see clumping, that means that it is present and will help us determine our patient's blood type. So I added about 2 or 3 drops of the anti-A serum. Now that they're both in the testing well, I take one of these black stirring rods and I will mix together these two liquids and try to look for clumping. I'm going to spread it out gently and try to fill up that whole space within the anti-A circle. Now, remember we talked about being sure we were mindful of our health and safety? Once I use a testing rod, I'm going to put it in that biohazard bag and not touch it again. Because also we don't want cross-contamination to occur, which is when you have things that mix together that aren't supposed to, and it can lead to inaccurate results. So I already have my anti-B set up and ready to go. And now I'm going to take 2 to 3 drops of the anti-B serum. I'm going to make sure none of that leftover anti-A serum is in the pipette. And I'm going to add 2 to 3 drops to the anti-B, stick it back in the test tube, and again, mix together those two liquids to see if clumping occurs. I'm going to be as gentle as possible. And then again, disposing of that stirring rod in the biohazard bag. And lastly, doing anti-D. Oh, I got ahead of myself here. I'm going to add 2 to 3 drops of the patient's blood, and then 2 to 3 drops of the anti-D serum. As you can see, I'm repeating the same process over and over again, which tends to be the case for medical lab technicians. They're repeating the same tests over and over again, and sometimes procedures within a single task can be repetitive. Again, I'm going to do it for anti-D, mix those two together, and then put that testing rod back into the biohazard bag. Now that I've actually mixed my liquids together, I need to record my results to make sure that people have documentation of what is my patient's blood type. And we need to actually learn from our results, right? So at the very bottom of the transfusion request form page, there is an opportunity for us to draw a picture of what we see and make a deduction as to are those antigens, those markers, present or not to help us determine blood type. So a really nice trick I have for you all, because sometimes it can be hard with the clumping, is to slightly move the blood back and forth, kind of teeter-totter back and forth to see if you can see clumps. And as I'm doing that, I'm noticing that when I move the anti-A well around, there's a whole cluster and clump of red blood cells moving around. And that, my friends, is agglutination or clumping. So that lets us know, hey, that A antigen is on the red blood cells of our patient. So if I'm looking here at my paperwork for the anti-A, there's like a little matching well here. I circled the plus symbol if there was agglutination or clumping, or I circled the 0 symbol if there wasn't. So I can go ahead and circle that positive sign for A, and I'm going to draw a picture of how there's this kind of clump of cells together and all these speckles around, letting me know that that antigen A is on our patient's red blood cells. So they have a type A blood. But wait, let's double check for B, because maybe they also have the B marker and they'll have type AB blood. So looking at our results from the test for the B antigen, I see it's kind of just like a clear liquid, and it doesn't have this clump that follows around the motion. There's a few little speckles, but see, oh my gosh, look at all of that clumping. You don't have that residual, those freckles almost, like those speckles of clumps, as you would in B. So I can circle the 0 for B and show that, you know what, it's just one kind of clear-ish liquid. Well, it's red, but you know, there's not those clumps. This patient has type A blood. That's it. B is not present. Looking at D, it is very similar to B, where there's not those clumps that slowly follow behind. I messed up on the D. Following behind and showing us that we have agglutination. So again, I'm going to draw a picture of how really it's just an unclumped liquid. So I circle, no, that's not present. Now as a refresh, D determines that antigen if it's positive or negative, a blood type. We don't have the D antigen, we know that because there's not clumping, so our patient would have negative blood. So they are A negative. So in blood type, I would circle A and negative. You'll see here on the paperwork, it says RH. RH is another word for D, that's all, for the antigen. So now I figured out my patient has type A negative blood. How cool is that? You just were able to learn how to blood type for a patient and figure out what blood they have. So our next step now is to figure out, will they be a match for our donor patient? And a cross match is when you take patient's plasma, okay, and mix it with the red blood cells of a donor. If clumping occurs, agglutination, which you're already experts at, we know it won't be a match. And the reason that it won't be a match is because that clumping would occur in the patient's bloodstream. And if there's clumps in our bloodstream, blood can go to where it needs to go and you get really sick or can potentially die. So that's why testing, doing a cross match is so important for the safety of patients who need blood transfusions. This blood donor identification card will help us determine and figure out these missing pieces to the documentation needed on the bottom part of our testing panel. So on this donor identification card, that long number in the very top left-hand corner is going to be known as the donor identification number, or DIN, as listed on your testing panel. As you can see, this number is super long, which makes sense considering so many people donate blood every single year to help other people out. So that's the donor identification number. The product code, as people donate their blood, sometimes it's separated out into plasma, platelets, or red blood cells. So there's certain codes based on if it's one of those parts of our blood. So underneath where it says volunteer donor, that number underneath that barcode, which starts with E, is a code to indicate that we have red blood cells. So we're going to copy that, E036V00. Underneath that is the expiration date, which I can see is right underneath this barcode, and it says that March 3rd is its expiration date. Great. And lastly, what is the blood type? Well, in huge big letters, this donor is A negative, so I make sure to mark that as well. what's a cool thing with medical lab technicians is that it breaks up between doing your procedures and also paperwork. So you get the best of both worlds, getting to work and also making sure that you're doing organization steps as well. So now that all my information is filled out, I don't need my donor identification card any longer, and I can actually get into doing my cross-match. So I have to get the patient's plasma first. I'm using a fresh new pipette. Again, not wanting to do cross-contamination, adding 2 to 3 drops, as similar to our testing before with figuring out the blood type of our patient. I have the donor's red blood cells, adding a few drops of that to our blood, using a fresh stirring rod, and again, gently mixing those two liquids together and looking for agglutination or clumping. And it looks like, ooh, so glad I wore gloves, right? Got a little bit of that on me. Put it in the biohazard bag, the used stirring rod, and I need to take time to observe my findings. So I'm going to try like before, be very careful and gentle, to kind of lean my testing panel back and forth, trying to see if I see that clumping. Oh, look, it looks really good right now with anti-A, seeing those clumps, okay? So I'm kind of wiggling it back and forth, and honestly, I don't see any clumping. So if there's no clumping, clumping wouldn't happen in the patient's bloodstream if they were to receive this donor blood. So it's safe and good to go to use for this patient. So similar to before, I need to make sure I document my findings, so then whoever needs to administer this blood to the patient knows it's a-okay to go. It's a-okay to go. Uh-oh, using the actual wrong utensil. So using my pencil at the bottom of the transfusion request form, just like before, I need to document my findings. So I'm going to say, is it a match? Is it incompatible? Do I need to retest or other? Well, this donor is a match, so I'm going to mark that. And again, I'm going to draw a picture. There was no clumping. I'm not much of an artist. Maybe you are. So I'm just going to draw that it was clear liquid with no clumping. So in this case, I would circle, again, the 0 symbol to mean that there wasn't clumping, positive symbol if there was. And I'm going to sign my name, so if anyone ever has any questions, they can come find me in the lab and ask me if my findings, if I thought I was unsure, or maybe I need to retest, or if there's any possible confusion. And of course, I need to date it appropriately, as you would always need to do with any testing. So now we've determined our patient can receive this donor blood and have their transfusion. And it's great because this donor blood won't go to waste with its upcoming expiration date. Now, when it comes to medical lab technicians, this is just one of many tests they could be asked to do. They tend to do the same task in a particular day, or maybe they're assigned that for a week, a month, or it's their full-time job. But as you learn to become a medical lab technician, you are trained and learn about all different types of tests, not just focusing on blood, maybe doing a urinalysis for a patient, which is testing of urine to figure out if they have diabetes. There's much more to medical lab technicians than just doing blood testing. But hopefully this gave you a great idea of what it's like to be a medical lab technician. So, lastly is cleanup. So with cleanup, I'm going to take my testing panel and carefully walk it over to a sink, and with warm water, it should come straight off. I might use a little bit of soap and dry it. And I'm going to make sure to keep my transfusion request form with all of my findings so I can refer back to it. With all of my solutions, I can dump those down the sink if I know I'm completely done with my testing and I don't need to retest. Also, with this biohazard bag, got to make sure that ends up in the trash as well. So, great job today. I hope that you had fun and learned something. You did stellar work as a new lab tech, and I hope to see you tomorrow.